Today we're going to review exponents and integer exponents, and just want to remind you that what is an integer? Recall that we had done this before. We had talked about the integers, and they are basically the whole numbers and their opposites. So -2, -1, 0, etc. Okay, all right. So we're going to talk about an integer or integer exponents and working with those. So let's say let's look at the notation. When we have an expression or a term written in the form a to the nth power, then the a is called the base. All right. And when we are looking at n is the power. That's our normal way of saying it. And we can also call this a power. It's an exponent. It is an index or indices. It's a plural. Okay. So these are the various forms. Now, while we can have fractions and so on, we're going to start off a little bit easy with what we call integer exponents. Right. And let's start off with one of the first rules that we learned. If we have, so let's go back. What does this a to the n mean? So taking n to be a nice whole number, we'd have n copies of a. So if I had a cubed or a to the third power, we'd have 3 copies of a. Oftentimes I will not put the cross, I'll just write a times a. The central dot will be preferred mode because I don't want to mix it up with say or x's as we go through. All right, so we understand the notation. Let's look at some of the rules that you've probably done, and you should, more than likely, you have some faint acquaintance or great acquaintance with them. So let's look at some of the rules and how to think about them, just in case you have forgotten. Okay, so one of the first principles that we probably remember doing was, if we were given a cubed times a squared, if we wrote this out in a long method, we'd have 3 copies of a times 2. So in all, I have a total of 5 copies of a, or 5 copies of this base. So I can write this as a to the 5th. This leads to the rule that if I have the same base and I'm multiplying 2 exponents to the same base, I can simply add the powers. Okay, so that was our first rule. Second rule, so this is sometimes called a multiplication rule or product rule. All right. Second thing that we have, let's go the other way, and let's write this as a to the 5th divided by a cubed. Again, going back to first principle, I have 5 copies of a in the numerator and 3 copies of a in the denominator. And we can just do our fraction cancellation. And so 1 copy of a cancels, another copy of a cancels, another copy of a cancels, and so we are left with just a squared in the numerator, and hence we can ask what is the general principle behind this. And so we can see that it appears that by dividing, these exponents or powers are being subtracted, right? So this is called a quotient or division rule. Okay. So far so good, I believe. All right, let's look back at some other things. Now, if I have, let's do a bit. Suppose I had a cube over itself. Well, in one way, if we wrote it out the long way, you'd have had 3 copies of A, and they would have cancelled down. We'd end up with 1, right? We'd end up with 1. However, this is nothing more than a division. So if it's a division, I can use the division property, and so subtract the powers. But that would lead me to get a to the 3 minus 3, which is a to the 0. So this shows that I have what we call the 0 exponent property. A to the 0 is equal to 1. Or 0 power rule, or 0 exponent rule. Okay. So this 0 power is nothing more than a special case of our division or quotient rule. All right, let's continue. And let's look at a fourth rule. Fourth rule that we want to look at, I'm still going to look at division, but this time, instead of looking at number 2, I'm going to write the reciprocal. So a cubed over a to the 5th. I'm going to do it my long way, which is 3 copies of a in the numerator, 5 copies of a in the denominator. Reduce, so 3 copies cancel in each part, and I would end up with 1 over a squared. But in a similar fashion to what I had done before in number 3, we have a division rule again. So if I apply my division rule, I get a to the 3 minus 5, which is a to the negative 2. So let's look at that a little bit more. So I'm saying here that a to the negative 2 is 1 over a squared. And if we take this or generalize this, we're saying a to the negative n is 1 over a to the n. So this is known as the negative power rule. Okay. All right. So these should be number 1 and 2. I know definitely most people remember. Number 3, 1 or 2 of you forgot that, but hopefully it's now come back to your memory. Number 4, this negative power, sometimes it gives 1 or 2 of you a little trouble. So keep it in mind. Think back to these simple examples. It's always useful. And as you're going through, don't just remember the rules by, rote memorization. It should connect to something that you actually know. Let's look at one of the last rules that I want to look at, and this is called the power of power rules. And so if I had a cube and I squared it, well, using that outer 2, this is a cube times a cube. And then whether you wrote it out the long way, you ended up with 6. And you begin to ask yourself, how could I get 8 to the 6th power based on what I have here. And so we would then have, or the rule that we have is a to the m raised to the n is a to the mn. So this is called the power of power rules, or the power rule. Let's generalize this a bit, because this is one that is a bit tricky for many students. So let's suppose we look at 5a. If I have, say, 2x squared y to the 4th power, and I raise that to another power outside. If I write this, I would write this twice. That times itself. But we don't want to always have to do this. Alright, so after looking at what we have, rewriting, putting all our numbers together, we ended up having this sort of, grouping like terms, etc. And we ended up with an answer of 2 squared, or 4 x to the 4th based on the product rule, and y to the 8th. But could we have done this faster? And of course the answer is yes. If we look on the inside, each item inside the bracket is raised to a power. The 2 is simply raised to the 1st power. And what you are doing is multiplying each of these power by the power on the outside. So you end up with exactly what you had, 2 squared x to the 4th y to the 8th. Right? So we can generalize our power rule, and although I've only shown a product here, if we said we had a to the p, b to the q, c to the r, all raised to the nth power, each item would be raised to the n. So that meant that the power on each term inside the bracket is raised to that power. So this is the general power rule. Okay. All right. So take a moment and look back. We can recap some of these. We're going to use them. So we have the product rule, which tells us that if we're multiplying terms that have the same base, we can simply add the powers. We have the division or quotient rule, which tells us that if we're dividing terms with the same base, then we can simply subtract the powers. If I have as long as it's not 0, but if I have a base raised to the 0th power, it is equal to 1. And as we go on, we have the negative powers, which is a little bit interesting because it's in a more general part over here, over in this part. What we're seeing is, if I look at this, if I have a negative power in the numerator, it's the opposite sign when I take it to the denominator, and vice versa. So although we won't write it differently each time, we will look at a few examples and see what I'm talking about in practice. All right, we have the power of power rules, or just simply call the power rules, and the generalized power rule for our exponents. Okay, so let's look at a few examples. All right, let's look at the first example. Now, I know when you met this initially, back in grade 7, grade 8, you were told that you had to write it out, say in this format where you showed everything. We're not going to do that. I'll do it for this one example just to illustrate a point. And then we are but then we're going to be doing it in the most efficient way possible. 2, 3, 4, 5, right? So this got a bit annoying back in the day when you used to do this. But the idea is having all of these products, what you were doing is regrouping. You were using the commutative property, which allowed you to group or regroup all the numbers to the front, all the C's or one variable together, all the D's together, 3, 4, 5, and all the E's together. So then I could simply put them together, and 2 times -5 was -10, C to the 5th, D to the 6th, and E cubed. All right, now that's all well and done, but we would much prefer to do it a bit more briefly. And so let me rewrite this: 2C cubed DE squared -5 C squared D to the 5th E. Now the point of me showing the first example, however, is that if you ever get tied up and you're not sure what's going on, there is no harm in writing things out and going back to first principle. All right, so if I were given this problem, I would simply write it as 2 times -5. That I would do combining my numbers or coefficients, if you wish. But then I would proceed. I saw that it was multiplication, so I would then show this 3 plus 2 for the exponent, for my C, for D, not shown but understood that this is, that this is D to the 1st power. So I would have 1 plus 5, and then continuing E to the 2nd, and in a similar way, this is to the 1st power, so plus 1. And we come to the same answer, but much faster. If I weren't talking, I'd be done a long time ago. D to the 6th, E to the 3rd. So here is my final answer. All right. Okay. All right. If I continue, there's our next example. And as we go through, we would look at multiplying -3. So the numerical parts, here is A. We'd have B to the 1 plus 1. Do try to show this part where you're adding rather than just leading to the final answer. It could lead to, if you made an error inadvertently, you'd at least get partial credit for putting things together. Okay, so here we go with our answer. Okay, so now that we have that, or we understand what's going on, let us look at some division problems and try from there. All right, so here we have a problem involving division. As we go through, what we could be looking at is each of these parts. All of the like terms are going to be combined using that division property. So the easiest way to go about doing this is if I divide -12 by -4, negative into negative, first of all, it's positive. 12 divided by 4 is 3. Then we could write our C to the 4th minus 3 and D cubed minus 1. E squared is not being divided, so it remains the same. Simplifying, I end up with 3C D squared E squared. All right. Any questions? Okay. So here we have a combination, multiplication and division. It's up to you if you want to complete the numerator before, or rather doing the multiplication before doing the division. However, I would probably do it this way. As I said, as you get better, you'll be able to look at it in the most efficient way. And while I will write this part, let's look at combining the variables. So a to the third plus 4. But there, 5 is on the denominator, so I subtract. I have m to the 4th power in the numerator, positive 5 in the numerator, positive 6 in the denominator, so I'll subtract 6. Right? So we've gotten rid of all our variables. Let's just simplify. Negative and negative is positive. The overall answer is going to be negative. 3 into itself is 1. 3 into 6 is 2. 2 into 8 goes 4. So I get negative 4. A to the 4 and 3 is 7. 7 minus 5 is 2. M to the 9 minus 6 is 3. Alright, so it works out pretty simply. At least these have worked out pretty simply. I promise that your homework won't be too difficult. Not yet. Alright, okay, so we understand this idea, and we are able to simplify these nice indices problems. Alright. Let's look at the power of powers, just to see if you have that or recall it. And so let's put up another problem. Okay, let's start out. So we have a single term inside the bracket, so it has to be raised to the 5th power. So we end up getting 3 times 5, or hence c to the 15th. So that would be my final answer. We have multiple terms, or so in our brackets this time, all being raised to the 2nd power. So recall that on the 3, this is essentially 3 to the 1st power. So I will be doing the same thing. I'll be using that general power rule. Each item inside the bracket is raised to the power on the outside, which means that the powers are being multiplied. Do not forget one part, or do not think that it's only applied to the variables. The numbers are there also. All right, so we ended up with 3 squared, m to the 8th. 3 squared is an easy enough number for us to find out or simplify. So 3 squared is 9, 9m to the 8th. All right, so we're expecting that you know powers, simple powers. It's expected that you should know up to, if we're looking at powers of 2, you should know from 0 to 10. And for 3, for 3s, you should know from 0 to 5. Okay. 0 to 5. Okay. Let's continue on and look at some more, or get them much more interesting now. I know you hate when I say interest. Alright, so this time I've decided to put up 2 problems at the same time, number 7 and 8. I want you to look carefully at them and try or attempt them, and let's see if they are the same or if they're different. All right. All right, so I'm gonna do this first one in a bit of a long way, and then do the short way on the other side. So I'm gonna divide up my board a bit in 2. So let's look at it in the longer way, and then we'll look at it in the short way. All right, So if I have this is negative 3d cubed e, and using the power on the outside, there are 2 copies of this bracketed term. If I now put them together, I would end up with negative 3 times negative 3, that becomes positive 9, d to the third plus 3, e to the 1 plus 1, or 9d to the 6, e squared. Let's look at the same problem in a short way. Okay. Now notice that this is one whole term, or you could look at it as negative 1 times 3. All right. So what do? I have negative 3 1 times 2, d to the 3 times 2, and running out here, e to the 1 times 2. So putting it all together, negative 3 squared, d to the 6, e squared. A negative number squared is always positive. Hence we ended up with positive 9 d to the 6 e squared. I wanted to do this both ways, although we will prefer for the efficiency the short way, because next time I could put the power on the exterior as some ridiculous power like the 20th power or so. All right, let's look down at number 8 now. Is it the same? All right, recognize that we have multiplication and powers. You should remember your order of operations, right? PEMDAS or PEMDAS, you will do indices comes before multiplication. So I must, when I'm doing this, I must do the powers first. So this is d cubed e and d cubed e. I must carry that part out first if I'm following my order of operations. What do I get? So bringing back my negative 3, here I can simply put these together, d to the 3 plus 3, e to the 1 plus 1, and hence negative 3 d to the 6 e squared. Doing this a short way, it's basically what I have over here, d to the third e squared. I would simply write 3 times 2. So there's no difference really in my long method, well, except I have addition versus multiplication when I'm using that power rule. So here I have addition because I've written the terms twice. I'm multiplying them, while here on the other side I'm using the power of powers. Okay. So I end up with the same thing, negative 3 d to the 6 e to the second power. Right? So as we go through and the questions get more involved, you still have to remember your order of operations and carry out things as needed, as required by or as determined by this order of operations. All right, so let's get a little bit more involved and try some things. We'll start out doing or working with numbers first only, and then we will do things with our variables, etc. All right, so that was number 8, I believe, right? So let's look at number 9. So going back a bit simple again, I'm going to ask us to look at this 10. right, so let's look at number 9. If I have negative 2 all to the third power, what do I get? Well, do remember that any negative number raised to an odd power will be negative. So this is really me writing 3 copies of negative 2. However, you could just write that it's overall negative, and then 2 to the third becomes 8. It's the same thing that we get over here, but recall that this is thought of as a little bit differently. Negative 2 to the third, or negative 2 cubed, is should really be stated as the opposite of 2 cubed. So in writing it, this is really negative 1 times 2 to the third. I'm following my order of operation. Powers must be done first before multiplication. So here we have negative 1 times 8. Yes, it comes out to be the same as the earlier part of number 9. But that all stems from it being an odd power. We'll see the difference in now with number 11 and 12. Again, the square is only acting on the 4, not the negative sign. So this is the same as negative 1 times 4 squared. Hence I end up negative 1 times 16, right? Doing my powers first, negative 16. Different thing here. It would be negative 4 times itself, which becomes positive 16. Could I look at this question a little bit differently? And of course, whenever you hear me ask that, you know that the answer will be sure. We can look at this differently. Now, let's think back. If in previous ones, I'm writing a negative, or the opposite of a number, as negative 1 times that number. So we could do the same thing here, right? So looking at these two terms, we have negative 1 to the first power, 4 to the first. I could apply my power of power rules. So this is negative 1 squared times 4, 1 times 2 is squared. Negative 1 squared is positive 1. Positive 1 times 16 is 16. All right. So any which way you need to look at this to make it more meaningful to you, please do. All right. Recall, maybe I should have written this. Recall that if I have negative 1 to the nth power, it is positive if n is even, and it's negative 1 if n is odd. So that might be useful as you go through. You shouldn't have any time, if I should give you, say, negative 1 to the 19th power, this should be a no-brainer. You should be able to write down your result in less than a minute, less than a second maybe. So it's an odd number, it's negative 1, all right? Okay. Right. I'm gonna write down a few more, and let's see what you get. Just practicing some things. Okay. So tell me, what do we get for number 13? Again, based on the definition, this will be 1. However, the next one will be negative 1 times 7 to the 0. 7 to the 0 is 1, so negative 1 times 1, or simply negative 1. A couple ways we can do this one. I'll start out and I'll write 3 to the negative 1 minus 2. 3 to the minus 3. However, we typically do not want to write our answers with a negative power. So I can use the negative power rule and bring this to the denominator. It now becomes 1 over 27. Right? Remember, we need to know all the way 3 to the 5th. Right? 3 to the 1st is 3, then 3 squared 9, 3 cubed 27, 3 to the 4th 81, and 3 to the 5th 243. Okay, let's do a few more and see what we can get. So let's mix it up a bit now. Alright, the next one here, number 16, you've seen me write it twice, which means that we're going to do it in two ways. I'm going to do it the first way. We're going to look at using our order of operations. So I'm going to be using our PEMDAS or BIDMAS, right? Sometimes I write BIDMAS, sometimes I write BIMDAS. It doesn't really matter. All right. If I do that, I need to work inside the bracket first. So I'm working inside the bracket. What do I get? Why don't I look at the 2's here? I have a division, so I'm going to do subtraction. 2 squared minus 3, and I'll just leave the 5 to the negative 2 alone. Alright, simplifying. If I simplify, I end up with 2 to the 5th times 5 to the negative 2, and I can't go any further in the inside. Alright, well, so now let's apply the power rule, right? So I apply the power rule, which means that each item inside the bracket is raised to that power. So 2, I guess I don't need the exterior bracket, to the 5 times negative 2, and 5 to the negative 2 times negative 2. So I end up with 2 to the negative 10 and 5 to the positive 4. Alright, we need to get rid of our negative powers. So our negative power rule, something is in the numerator, or I can write this as 1 over 2 to the 10th, which would mean that the numerator is 5 to the 4th. Alright. Alright, so we could simplify this a bit. This is my... Alright, and so if we evaluate this, we would get 5 to the 4th would be 625, 2 to the 10th would be 1024. So this would be our final answer. But you should really know these powers of 5 and 10, but I wouldn't penalize you if you left it in the following way. So if you gave me this as your answer, that would be fine also. Alright, now I've shown that would be our preferred way of doing this problem because we have followed the order of operations. But we again would not penalize you if you had proceeded by using the power of powers out here, and so you're applying the power rule. So if you apply the power rule, let's see if we would get the same answer. And so we'd have 2 times negative 2, 5 negative 2 times negative 2, and 2 to the negative 3 times negative 2. What do I end up with? 2 to the negative 4 times 5 to the 4th, and 2 to the 6th. Now the only power that is negative is in the numerator. Based on the negative power rule, it says that I can use a to the negative n is 1 over a to the n. All this is saying is essentially, if I think about this as being in a numerator, I can move it to the denominator or vice versa to change the sign. So I'm going to just do that with the one term that we have. So I'm going to remove the 2 to the negative 4th from the numerator. I would have 5 to the 4th is left. Bringing that to the denominator, it becomes positive. I can now combine these two items and I end up with exactly the same thing that I had from before. 5 to the 4th over 2 to the 10th, which is 625 over 1024. All right, let's see how you're proceeding on both 17 and 18. If we look at these, first one is simply multiplication. I can regroup, have all my numbers together, my numerical coefficients, and then I have x squared, x to the 5th, y cubed, and y. So this is 6, x to the 2 plus 5, and y to the 3 plus 1. So 6x to the 7th and y to the 4th power. Right? Continuing with number 18, we have to do the powers first. Oops. So we'll have to apply the power rule first to both the numerator and denominator, or we'll choose to do that, I guess. So we have 3 to the 2nd, x to the 2nd. See, I've now gotten it. I hope everyone can follow now. All right, or do you want me to write out all the steps? Remember, each of these was to the 1st power. So all I'm doing is I'm multiplying each by that power on the outside. All right, so going to be a little colorful here. Yeah. All right, and I'm going to do the same for the denominator. So I'm saying that you are moving up and you're understanding more. I heard some complaints about me writing stuff, too much stuff, so I'm compacting it. All right, so we've compacted it, we've multiplied, we've gotten rid of our brackets by using the power rule. We have some negative powers. We have division also, so we could even combine here all my x's, variable y's. Have a little problem here, so I'm also going to move that so that we don't typically think very well with negative exponent. If you do, all the better for you, but most people don't. So I'm going to use this and I'm going to write what we have here. By moving this 2 to the negative 2 from the denominator, it comes to the numerator as a positive power. 3 squared remained. The x's I will subtract. I'll also do the same with the y's, although I could have done it another way. All right, and so what I now have is 4 times 9, x to the 4th power, and y to the negative 4. 4 times 9 is 36, x to the 4th, but the y to the minus 4, I want to write my answer with all positive powers, so this is what we have. Right? Any questions? Okay. Right, so all we were doing, we were just subtracting negative 6 minus 2. Watch your signs. See, the time that I didn't slow down, you now have all those questions. All right, let's go on. Keep going. Have a couple more minutes for this class. Right. Let's look at number 19. We have two ways of doing this. The -1 is really a way of writing the reciprocal of whatever is inside. So the fastest way to do this is just to flip everything on the inside, and we end up with our answer 2y over 3x. Let's do it a little bit slower. So let's take it again, and we will write this. We'll expand. So again, bear in mind each of the powers on all the terms in the bracket are to the first power. So I would end up 3 to the -1, x to the -1 when I multiply the powers, 2 to the -1, y to the -1. However, using a negative power rule, everything to get, if something's in the numerator and it has a negative power, I would move it to the denominator. So these would be moved to the denominator. But similarly, if an item is in the denominator, to get it to be a positive power, I would need to move it to the numerator. So that's the cleanest or fastest way of writing some of these things. So we would have 3 would be on the denominator, or 3 to the first, x to the first. I'll put back the 1, it's a bit redundant, but I'll take them out shortly, and y to the 1. So we simply get our answer that I had taken less than a minute to do, and we have this. Alright, let's see if you have number 20. I should really have given you one more in between that. Let's hang on this, and let's try something else first. I want to see if you really get it. So suppose I have 2x over 5y, let's do 5y squared, and this time I want -2. Well, let's see what you do. Yes, that's the squared. Right. Right. So let's again look at this in two ways. Bearing in mind, I know you're getting tired of this, but whenever you don't see a power, it is to the first power. So we could do it this longer way: 2 to the -2, x to the -2, 5 to the -2, and y to the -4. Each item that is in the with a negative power, I will move its position to get rid of that negative. So 2 squared comes down the denominator, likewise x squared. So the entire numerator moves to the denominator to become positive exponents. Likewise, the numerators move to the likewise the denominators move to the numerator and become positive powers. I now have 25 y to the 4th over 4x squared. This is my final answer. If you're fine with that method, that's great, but I'm going to look at it in a different way. All right. So let's rewrite this again. We have 2x over 5y squared. It is raised to the -2. I'm going to look at that -2 as -1 squared. Let's see what we get. So working inside my bracket here, whenever I have a -1, just remember what we did in number 19, right? Whenever I have a -1, it's taking that reciprocal, right? And so the entire inner bracket, I can work there. Let's bring back the squared. So that inner bracket can be replaced with its reciprocal, 2x. And now proceeding to square. Each item is squared. And so I have, and so I have 5 squared y to the 4th over 2 squared x squared. 5 squared is 25 over 4 x squared. Same answer, just turned around a little bit differently. Okay. Again, choose whichever method you prefer. All right, last one that I had written up here. Well, let's not end with an odd number. So we will do this 21, a to the minus 1 minus b to the minus 1. So I want to write this so that all the exponents are positive. So if I start out, I would get 1 over a minus 1 over b. If I told you this is fine, if I wanted as one term, then the denominator would be ab and b minus a, and this would be our final answer. All right. Notice this is a sum, not a product. 22 and 0. All right. So let me know when you have solved this. You should be done. All right. I don't care what is inside. This is all raised to the 0th power. Hence my answer is 1. Simply 1. Okay. So don't get caught. Some of you were looking and doing everything on the inside, which is great, but you'd still end up with 1. Right. So, all right, just to humor some of you, in here you would have had b to the minus 6, but this is all redundant. A to the 4th, I would now have ab over a to the minus 2, all of this raised to the 0. Still working inside the bracket. Why am I doing this? I don't know. Somebody asked. And so you'd have b to the minus 6 plus 1, a to the 1st, minus 4, minus 2, all to the 0. So yes, if I wanted to simplify inside, maybe that's your goal. You're looking what's inside. 3 minus 4. So a to the minus 1, b to the minus 5, all to the 0. This is the same as 1 over a b to the 5th, all to the 0th power, which, as we said, is simply 1. Right? Could have gotten there a long time. So do not take the long path. We want you to get the expedient. All right. Okay, so with that, the key things that you need to remember, please, are your rules of indices. We're only doing the integer rules right now. We'll go on to the fractional powers, etc., and see what you can do. You need to remember your power rule, your product rule, your quotient rule, your zero power rule, your negative power rule, and your power of a power rule, or the general power rule as you go on. Yeah, question coming in. Oh, right, I did have you doing some homework. Right, I had you looking at some exercises before. Okay, let's look at, all right, so we're not done. Let's look at some of the exercises that you had based on your readings. So let's look at number 23. You were given part A. minus 3, find a solution, or what is the final answer. So we had some of these things. 1 over negative 3 to the minus 2. And the third one, which is 1 over negative 3 all to the minus 2. Alright, so again, as we had said, this is negative 1 times 3 to the minus 2. What exactly is this part? So we would end up with negative 1 over 3 squared, so negative 1 over 9. The next one, part B, again, the negative, or the power, is only acting on the 3, so it's really me having 1 over negative 1 times 3 to the minus 2. So I'm going to move that 3 to the minus 2 to get a positive power. It becomes 3 squared over negative 1, which is 9 over negative 1, or negative 9. Alright, continuing on, part C, the bracket. The placement of the bracket is important. I just wanted to remove the my circle from part B. Alright, so if I look at part C, you would have 1 over, the bracket term is negative 3. So I would have negative 3 squared when I try to get rid of the negative power. So in the numerator, I simply have positive 9 over 1, which is 9. Okay. Alright. There, 24. Or modulus. Alright. So if we worked on this, since the term being squared, it's only the 4, so this would end up being negative 16, while everything here is being squared. This is positive 16. Okay? Let me write it. So positive 16. 4 to the 0 is 1. And now working inside the grouping symbol, this time it's an absolute value or modular symbol. Minus 4 is minus 8. Going through, I have negative 16, get rid of some of these double signs. The modulus of minus 8 is simply 8. Putting everything together, negative 16 plus 16 is 0, so I end up with minus 1 minus 8, right? Those go away, and hence negative 9. Number 25. Alright, the main difference between number 24 and 25 is 24 is just testing your knowledge of your negative 3 and 2s and so on, versus just one single number. Again, the same idea. First term will be negative 9. Negative 2 cubed would be negative 8. Oops. And 2 to the 4th is 16. Working inside the absolute value, I get negative of negative 27 minus 9. Alright, keep going. Minus 9 plus 8. Get rid of those double signs. Minus absolute value of positive 27 minus 9. Looks a little crowded, so let me move up. Minus 9 plus 8 minus 16. Working in here. 27 minus 9 is the absolute value of 18. We can get rid of the absolute value now. Okay. Alright, and what do we have? We have combining negative 1. So negative 17, negative 17, and 18, that's negative 35. Right? Okay.